Hello guys, today we are going to talk about how the DHCP snooping attack happening, and also we will talk about how we can protect our network from the DHCP snooping attacks. Okay, so before that I'm going to review how DHCP is working, right? So we need to know a basic idea how DHCP is working. So in this topology, this is very simple topology here. So I'm going to configure this router as a DHCP server. So this will be the DHCP server here. Then we have a DHCP clients Windows machine, and then we have one Linux PC. This is a Kali Linux. So I'm going to launch an attack from this Kali Linux PC. So before that, I'm going to talk about how the DHCP is working, right? So, basically, what will happen once the DHCP is enabled? So you have to enable your network interface card to get the IP automatic, right? Uh, it should not be static configuration. You should enable the PC here as a automatic IP mode. Then it will send the DHCP discovery message to as a broadcast traffic to the network, right? So we know the once DHCP works, it we call is the DORA process, right? So DORA is it's a discovery and offer and reply and acknowledgement, right? So these are the four the step once the IP assigned. So once the client enable with automatic IP, it will send the DHCP discovery message. So it will be it will be the broadcast message. So it will be sent out over the layer 2 segment. So it will reach to the router here and go to the other PCs which is in the same layer 2 environment. So once the DHCP server, we have enabled DHCP server in the router. So it will accept the discovery message, then it will immediately send the DHCP offer message. So it will be have all the details of IP, the IP address, and the default gateway, DNS, and all the sort of things will be sent out with this offer message, right? So once a client accept the offer, so it will be assigned to the IP address into the machine, then it will send the reply message. So the reply packet will go to the server, then server will accept, then it will send the acknowledgement packet. So then the communication will be closed. So the PC will get the DHCP IP from the DHCP server. This is the basic DHCP process work, right? So what's the security concern is here is if you have another DHCP server in the same network, for example, the attacker here is the attack machine. Okay, so if this machine act as a DHCP server or rogue DHCP server, so what will be the issue? So what will be the issue? So this discovery message can reach to this attacker machine as well, right? So if the attacker machine send the offer before send the legitimate DHCP server, so the IP will be assigned from the attacker machine DHCP offer. So then the client will get the wrong IP address, which not belongs to the legitimate network. So it will be the range offering from the IP address range will be offering from the attacker machine. So so in order to protect this, we have some protection mechanism. So before that, we will learn how this process happening. So the normally DHCP snooping attack will happen in the two steps. One, the attack machine will attack the server. So it will attack the server. It will utilize all the IP range, which the DHCP range. That means that IP range which assign for the DHCP server. So, for example, for let's say we have 192.168.100.0/24 network. So we'll be have around 254 IP addresses. So so the attacker machine will send some faults, the discovery message, and it will claim all the IPs from the pool, from the DHCP pool. Then there will be no any IP left to offer to the legitimate client. So then the server will be fully utilized with the DHCP range, that IP range. It will be offered and it will be utilized fully. Then the client could not able to claim the IP from the original DHCP server. So then the attacker machine will launch, will send the this will start send the offer from its from the machine. So that offer will be the raw DHCP server. So it will be that offer will be go from this raw DHCP server. So the client will accept that offer, right? Because the original server cannot send any offer because it's already utilized with all the IPs. So it will accept the offer from the rogue DHCP server, that is the attacker machine. Then it can able to take control of the client machine from the attacker, right? So this is the DHCP snooping. So we are going to I'm going to show you how this working actually. Okay, so let me start these two machines. So let me configure first this router. So I have already configured the IP address for this interface G00. So it's already configured. So I'm going to create a DHCP pool, IP DHCP pool. Let me see XYZ. So I'm going to say the network 192.168.100.0/24 network, and the default gateway will be 192.168.100.1. that is the interface of my router interface which connecting to the switch. I'm sorry. So DNS server is I'll put the Google DNS. So domain name, let me xyz.com. Okay, done. So let me verify the configuration. Show run IP DHCP pool. So this is my simple DHCP server. Okay, I have enabled DHCP pool here. Uh, that's it. So in the switch, I have just a normal flat configuration. I don't have any specific configuration here. So I don't have any VLAN, just it's in the default VLAN 1. So I have connected all the these nodes in the same VLAN. Okay. So let me start this machine. First I will start the Windows machine. Okay, I already configured this Windows machine as a the IP address to automatic. I didn't configure any static IP. So it's already automatic. So it will get the DHCP IP from the server. So let me configure, let me verify the IP address. Show IP config. I didn't get the IP yet. Still, it's in that. Okay, IP config. Let me say renew. Okay, you can see here. It's received the IP from my DHCP server, that router. So IP is 192.168.100.3 on my default gateway. So I could able to ping my default gateway 192.168.100.1. Okay, I can able to ping my gateway. So this is a normal operation, right? So the client requests the IP, then the DHCP server send the offer. So it's a normal operation. We don't have any problem with that. Okay, so let me go to my CLI in the router. Okay, let me see my DHCP binding. Show IP DHCP binding. You can see here the router has offered one IP for my Windows client 192.168.100.3. So far we have utilized only one IP out of 254 IP. So I forget one thing. I have to exclude this default gateway IP address from because the DHCP server should not offer this IP to any client because it's the default gateway IP, right? So let me add this command DHCP exclude address 192.168.100.1. Okay, so the server will not offer this IP. Okay, so let me start my attacker machine, that is the Kali Linux. So I'm going to launch DHCP discovery attack. So I'm going to uh, exonerate the entire IP pool. Okay, first let me check my what is my IP currently. Yes, for my attacker machine, we received the IP 192.168.100.2, right? So let me go and show IP DHCP binding. So far we have utilized two IPs, one for my the legitimate client, that Windows machine, the another one this 192.168.100.3, and for my attacker machine, that is 192.168.100.2. So far we have only just two IPs from the pool. So I'm going to launch the attack now. So this is a kind of DDoS attack. So not only DHCP server utilize the for all the IP, and also there will be some CPU hog or the over resource issue will come in the switch end. Okay, because we will fill up with the MAC address table. Okay, with the wrong MAC address. That means the rogue MAC address. Okay, let me start now. I'm going to call the tool Messinia. Just give me a second. I think it's installed. Sorry, I typed the mistake. Yes, yeah. Okay, guys, this is the tool. I'm going to launch the attack. I'm going to launch the DHCP attack. Okay, so let me. Okay, guys, I'm going to call my tool the Yersinia. So I'm going to launch the attack now. This will be my DHCP attack. I'm going to send the discovery packets. Okay, so I'm going to send the huge discovery packet counts. Okay, Okay, let's start now. You can see here it just sending it's bombarding the huge amount of packets towards my DHCP server. Okay, let me go and check my DHCP server status. Show IP DHCP binding. Look at this. It utilized entire IP pool, right? So you can see here the MAC address. It's completely, the rogue MAC, the false MAC address. So it's not a legitimate the MAC addresses. So you can see now it's completely utilized all the IPs in the pool. Okay, let me see about my switch condition. So you can see I cannot type anything in the CLI. It's hanged the switch uh, because I'm sending tons of packets. So let me stop this attack now. Stop. Okay, I stopped the attack. So just wait some time. Now the switch came back, I think. So just show MAC address table. Look at this MAC address table. It's filled with the all false MAC addresses. So switch is too slow now because it's handling the huge up request, right? It's filled with the MAC address table is filled with all false information, right? So it will take some time to recover to normal position, to the because the CPU utilization and memory utilization went high. So now you can see here we have now this IP is already utilized. So let me check my Windows machine. Okay, I'm going to renew my IP address. We'll see whether I can get new IP or not. Okay. First I will release the IP. Release. Now I'm going to renew again. So I have to get new IP. We'll see what will happen. So already we have utilized all the IPs in the DHCP server. Yes, I got the IP. Maybe because why I got I already having the record for that. So let me release. Okay, I'm going to release the IP again. So let me clear out all the DHCP offers. Okay, clear IP DHCP bindings all. So show IP DHCP binding. You can see I don't have any offers now, so it's a completely blank table. So let me start the attack again. I'm going to launch again the attack. Again, I'm going to send DHCP discovery. Okay, you can see here again. I'm start the attack. It's bombarding the large count of discovery message. Okay, let me see again my table. Look at this. all the IPs are utilized now. So you can see the switch will be hanged up. Switch got hanged up now. So let me stop the attack. Okay, look at this now. Let me wait my switch come back to normal. Now the CPU and the memory will be okay. Now it's coming back normal. Okay, let me try to renew my IP in the Windows client. It should get the new IP, but we'll see. You can see I'm not getting. I don't. It will not take this much time to get the IP, because why? The server will not send any IP because why? It's already utilized with uh, the entire address pool. So so you have to wait some time to get the least time to expire from some other client. That means from this attacker machine offered. So you have to wait for some time to get clear this DHCP pool, or otherwise we can clear out from IP DHCP binding command. So otherwise you have to wait until this least time to expire. Okay guys, so this is the DHCP snooping attack. So we are going to discuss now how we can protect from this attack, right? So how we can protect our network environment from this kind of attacks. Now you can see here one more thing. Now I just forget one more thing actually. I'm going to show you now how this attacker is going to turn his machine as a DHCP server now. Okay, currently I could not able to my legitimate DHCP server could not able to offer any IP because of the pool is full. So now I'm going to launch the attack to the client. So I'm going to launch the attack to the client as the rogue DHCP server. So I'm going to be a rogue DHCP server. So I put my server. I will put the completely different IP range here. For example, I'm going to put server ID here. So my starting IP 10.10.10.1, 10.10.10.254. So least time I would say 300 second. Renew time 100. Subnet mask 255.255.255.0. My router 10.10.10.10.1. The DHCP server, I put the Google DNS xyz.com. Okay, I'm going to make this server, the attacker machine as a rogue DHCP server. Okay, so I did now. So let me go to my Windows machine. So it could not able to renew the IP from the legitimate server. So we'll see which IP we are getting now. Look at this IP. This is not the original server. So we have 192.168.100.100 range. That is the original the legitimate IP range. But we are getting 10.10.10.10.1. This is completely from the attacker machine. Okay. So you are able to reach your attacker machine 10.10.1, I suppose. Yeah, it's pinging now. You can see here. Sorry, I think 2, I suppose. No. No, you cannot able to reach, but you can see here you are receiving the completely false IP from the attacker machine. So because why your the legitimate DHCP server could not able to offer any IP as long as it's all the IP pool is full, right? So okay, let me show you one more thing. How we can protect this one. Okay, let me clear out this. I will stop my attack. Okay, already stopped now. So clear IP DHCP binding. So I'm going to clear all. Okay, so let me renew again. I'm going to release the IP which already assigned from the attacker machine. IP config release. Again, I'm going to renew. Okay, you can see here I got the IP from the original DHCP server. Okay, how we can protect this attack? Okay, so we have to do this in the layer 2 device, in the switch. So we are going to enable IP DHCP snooping. Okay, once you enable the snooping, the in the global mode, the switch will untrust all the ports. All the ports will be untrust mode, so it cannot send any DHCP discovery message from any port. So that is the basic thing will happen on that. So it will stop pass DHCP discovery message as soon as you hit this command. So, and also you can you have to mention this DHCP snooping is for which VLAN. So you can able to give the range of VLAN, or you can give one VLAN. So I'm going to give the VLAN 1. Fine. So just go and check now. Show IP DHCP snooping. So look at this. I think I already have configuration on G0. Let me G00. Let me release. Okay, show IP DHCP snooping. Look at this. Sorry, one more thing I have to remove. Actually, I just test this. I have to remove this command first. Okay, please ignore this. Okay, now I'm going to show you how the default show command will show you about the DHCP snooping. IP DHCP snoop. So you can see here when you type the IP DHCP snooping, what are the VLAN? We have enabled the snooping feature, and uh, here you can see the interface. What are the by default all the ports will be untrust. Okay, once you enable DHCP snooping, default behavior will be it will untrust all the ports in the switch. Okay, then you have to go and the trust the port which the DHCP server is connected. Okay, in my case, uh, here will be here will be we have 3 ports, right? So as soon as you enable IP DHCP snooping feature, uh, this all port will be untrust. Okay, this all will be untrust. So then you have to manually go and trust the port which DHCP server is connected. Okay, so what will happen once you untrust? It will not pass any DHCP discovery message. So so we have to enable we have to enable this port as a trust port. Okay, this will be the trust port. So the DHCP server is connected. So here what we'll do? So here we will set the rate. Okay, so we will say only 5 packets, 5 discovery packets can be sent through this link, through this interface per second. Okay, if it is sending more than 5 packets per second, for more than 5 discovery packets per second, it will block the port. Okay, it will go for the error disable mode. Okay, that is the mechanism we are going to configure now here. Okay, so let me bring back my CLI here. Okay, I'm going to say my interface T00 IP DHCP snooping trust. Okay, I'm going to trust this interface because my DHCP server is connected on that, and my all other ports, my interface D01, I would say the range interface range G01 to G02. It will cover my these 2 ports. The attacker machine also will be there. Okay, I'm going to say IP DHCP snooping. So I'm going to set the limit rate. So I would say just 5 packets per second. Okay, so I will allow only 5 packets per second the discovery. So if it is violating this rule, it will go for the error disable mode. Okay, the port will go to the error disable. Okay, done. So now we will launch attack again. We will launch and again a discovery DHCP exuser. Let me open my Kali. Okay, again we are going to launch the attack. I'm going to send discovery packets. Okay, it's sending here. Look at this, what switch is saying now. So you can see it's sending the packets continuously, but we don't have any issue with the switch because before it was hanged. But you can see here, okay, let me stop the attack. I don't want to crash this machine because it's sending tons of packets. So let me stop this. So, okay, look at this. The DHCP Snooping received 5 DHCP packets on the interface G02, right? The snooping rate limit exceeded. Okay, the interface receiving more than the threshold set. So this is the rate error detected on the port G02. It's putting in error disable state. So the port is going to the error disable state, and then you can see here the port is going to shut down. So show IP interface status. Sorry, so interface status. Look at this. The port is now in the error disable. So as long as it violate the snooping rule, the rate limit, switch will put this port into the error disable. It will not accept any packets from the attacker machine. Okay, so let me go and check now. Our DHCP server is safe. So we don't have any issue with that. So if you want to make it release this, you have to shut down the port and make it up again. Okay, the port will be come to the normal. So this is the protection mechanism. So I will repeat again. You have to enable IP DHCP snooping feature. That is a global configuration. Then you can enable it for the VLANs. So which VLAN you want to enable this feature. Then as soon as you enable DHCP snooping, all the ports in the switch will go to the untrusted mode. Then you can able to trust the port which the DHCP server is connected, or DHCP traffic, the server traffic need to receive. So those port you can enable as a trust. Then you can configure the DHCP snooping limit rate for all other client connected ports. Okay, so this is the mechanism how we can protect from this DHCP snooping attacks. Okay, thank you for watching, guys. Bye.